Hello everyone, this is Miss Ling. We're going to go through question 3, which is part 1. Now, quite a number of you perform poorly in this part, basically because you cannot recall what you learned about trigo in your secondary school. Now, please do note that whatever that you learn in your O-level, okay, or for your JH Math, they are assumed knowledge. So you have to recap, with ease. So let's look on to part 1. Part 1, we are asked to find h, and which is the length from B to C. So looking at the diagram, okay, with the context in place, we have to try to figure out, are there any suitable common geometrical shapes to help us to find h. So what are the common geometrical shapes? You can play with triangles. So we try to find what are the appropriate triangles that we can play with. For example, we can have the triangle OAS, where AS is perpendicular to OC. Also, we can find another triangle that is ABD, where AD is parallel to OC. So seeing this, with these suitable triangles, right, with the constructions of suitable triangles, we can easily find what's h. H can be found by taking C to D plus the length from D to B. So how do we find CD? It's actually equal, it's of the same length as SA. So to find SA, very easy, because we saw a right angle triangle, which is OAS. And in the triangle OAS, we have the angle theta, we have the length of OA to help us, so we can make use of Picasso to find SA, the length of SA, which is A sine theta. Now how about DB? To find DB, we can make use of this triangle ABD, but unfortunately, we do not know what is this angle, and we have to find ways to find what is this angle, BAD. So what is this angle BAD about? You have to look at the big picture, ask yourself, I have the angle 2/3 pi to help me, it's given to me, and how can I make use of this 2/3 pi? Of course, we can make use of this angle here, which is power 2 minus theta, and we know that this angle here is the corner of the rectangle, so which is power 2. So with the knowledge of angle at the point is made up of 2 pi, which is 360 degrees. We can find this angle BAD easily by taking 2 pi, subtract 2 pi third, subtract power 2 minus theta, as well as this power 2. That will give us power 3 plus theta. So with this angle BAD known, we can make use of this right angle triangle to find the length DB, which is B sine power 3 plus theta. Now this is not the end yet, because we are asked to show in that certain expression. So how? We can't use our formula, because our formula involves two terms, two different trigo terms, of which one of them must be sine, the other must be cosine, and the angle must be common. So obviously down here, in the expression that we have as of now, we can't use our formula. So we have to think of, okay, you can flip to your MF26 to figure out how do we simplify sine power 3 plus theta, which is the compound angle formula. So as we simplify sine power 3 and cosine power 3, now these are special angles. You must know the special trigo ratio as well. So we do not expect you to use calculator and press out the value. You must remember their trigonometrical ratios. So as I simplified, that will give us to this simplified expression. So in this simplified expression, we saw two terms. One of them involves sine theta, the other term involves cosine theta. And to get into that expression that we wanted to show, you notice that in the shown expression, there's only one trigo term, which involves sine. So hence, that reminds us of our formula. So I need you to recall A sine theta plus B cosine theta. The R formula, the R is found by taking square root of the sum of the square of the coefficient of sine theta and the square of the coefficient of cosine theta. Now, because the first term involves sine, so I use the R formula on sine. And the common angle is theta. And because it's addition, so we follow the sign. And the alpha will be taking tangent inverse B over A. Now, you need to recall the R formulas. So I will leave that job to you. So with this, we are applying the R formula on this expression. As I expand the square of A plus half B, as well as the square of square root 3B over 2, that will get me to, I should be able to simplify to A square plus AB plus B square. Now, how about alpha? How do I determine alpha? Recall. So, therefore, your alpha will be tangent inverse the coefficient of the second term, which is B square root 3 over 2, over the coefficient of sine theta. Now, you cannot leave this form because it's not simplified yet. So, you must learn to manipulate. Okay, you must learn to manipulate to simplify your algebra. So, that will get us to square root 3b over 2a plus b. So, therefore, we have shown the expression where alpha is actually tangent inverse square root 3b over 2a plus b. Okay, we are still at part 1. I need to show you there's another method to go about to show h without the use of our formula. Now, to find h, if you look at the diagram, we could come up with another triangle to solve for h, which is the bigger triangle. We have to construct a line from O to B. So we will make use of this triangle OBC to find h. So we can make use of sine angle OBC equals to h over OB. Now, how do we find the angle OBC? Now, angle OBC is not just theta itself. You have to let this angle here to be alpha. So, angle OBC can be taken as theta plus alpha, where OB can be found by taking a look at this triangle OAB, because these are the informations given to us. We are given OA as A, AB as B, and we are also given that angle at OAB is 2 pi over 3. So why not make use of all these pieces of information to help us? So which we can employ cosine rule. So you have to recall your cosine rule formula, which is taking square root of a square plus b square minus 2ab cosine 2 pi over 3. And please, you must learn to evaluate correctly the value of cosine 2 pi over 3, which will give us negative half. So that will give us a square plus b square plus ab. So this is the length of OB. Now, how about alpha? How do we solve for alpha? Because we are told to find alpha in terms of A and B. So looking at the triangle again, OAB, we can make use of the side and the angle to help us to find alpha using sine rule. So using sine rule, alright, we can compare sine alpha with its opposite side, which is B, equals to, we can compare with sine 2 pi over 3 with OB. So using the sine rule on this alpha and the angle 2 pi over 3 and their corresponding opposite length, we can figure out what's sine alpha, which is B. Sine 2 pi over 3 is equivalent to sine pi over 3 square root 3 over 2 over, earlier on we know what's OB, which is square root a square plus b square plus ab. So upon simplifying it, we have square root 3b over 2 square root a square plus b square plus ab. So therefore, we are able to show that h is OB sine theta plus alpha. And alpha is sine inverse square root 3b over 2 a square plus b square plus ab. So this is the alternative method to show h. Of course, the alpha that you found in this method, it is of different expression from your previous method, which in the previous method we make use of the R formula. Now there are some of you who actually use cosine rule to find alpha, where your alpha is cosine inverse 2a plus b over 2 square root a square plus ab plus b square. That is acceptable as well, because the answer is correct. Let's move on to part 2. Now in part 2, we are asked to find the rate of change of theta when theta is pi over 12. So what are we given? We are given that h is decreasing at a rate of 0.5 meter per minute. So in other words, we are given dh dt equals to negative 0.5. Now, quite a number of you forgot to put the negative sign. The negative sign is important because that indicates that your h is decreasing at this rate. So for those who who is not aware to put in the negative sign, and that definitely affect your accuracy in your final answer. So how do we begin this question? So first of all, you got to ask yourself, what is the relationship between h and theta? Do we have the relationship between h and theta? Yes, we do have, and it's from part 1. So from part 1, we are given, or we are managed to show that h equals to a square root a square plus ab plus b square sine theta plus tangent inverse root 3 b over 2a plus b. So with this relationship, before that, let's put in the value. A equals to 1, b equals to 2. So therefore, my h is square root 7 sine theta plus tangent inverse root 3 over 2. So with this relationship between h and theta, we can form the connected rate of change of formula between dh dt and d theta dt, which is dh dt equals to differentiate h with respect to theta and the rate of change of theta. So therefore, we need to find out what's dh d theta then. So at this side here, differentiate h with respect to theta is root 7 cosine theta plus tangent inverse root 3 over 2. So differentiating the angle, which is theta plus tangent inverse root 3 over 2, that will give us 1, okay, in the coefficient. So therefore, we have d theta dt equals to negative 0.5 over square root 7 cosine theta plus tangent inverse root 3 over 2. So what is the value of theta that we're going to put in? They ask us to find the rate of change of theta when theta is what? Pi over 12. So we're going to key in that into the calculator. So with the calculation, everything you input, you punch in the GC, we get negative 0.337. And the unit for this rate of change of theta will be radian per minute. You have to take note of the unit. The time is measured in terms of minute, not second. So there's quite a number of you got deducted presentation mark because you put down the wrong unit. And the angle is measured in terms of radian, not degree. So again, for students who write down degree per minute, radian per second, you got deducted presentation mark. So please take note, be aware of the unit that is given. Alright, we are at part 3 now, the last part of question 3. So in part 3, we are told that theta is small, and we are supposed to find the approximation for h. How do I know it's an approximation? Because we saw the approximate sign here. So we need to find approximation for h, and this is the expression for the approximation for h. So we have to begin with h equals to root 7 sine theta plus alpha, where alpha is actually tangent inverse root 3 over 2. So in this expression here, please take note that theta plus tangent inverse root 3 over 2, this is not considered small angle. Alright? Which you cannot apply the small angle approximation on this angle because this angle is not considered small. So you cannot apply the small angle approximation directly onto it. There are quite a few of you who actually did that, which is, it shows that you are unaware of the condition. Okay, what are the conditions before you can actually apply small angle approximation? So what we can do is we have to break up the angle. So how do we break up? We will make use of the compound angle formula from MF26. So with that, how am I supposed to find the exact value of cosine tangent inverse root 3 over 2 as well as sine tangent inverse root 3 over 2? Because in the questions we are told that the value of P and Q are to be in exact form. So you're not allowed to use GC, you're not allowed to use GC to have the string or decimal place to convert to fraction for you. So how do we figure out? So on the side track, okay, we know that this is alpha. Alpha is equals to tangent inverse root 3 over 2. So therefore, tangent alpha is equals to root 3 over 2. So with a right angle triangle, let's label this angle as alpha. Let's put in the side square root 3 over 2, and by using Pythagoras theorem, this hypotenuse side will be square root 7. So with this right angle triangle, we can figure out that sine alpha is equals to root 3 over root 7, as well as cosine alpha is equals to 2 over root 7. So with these exact values known, we can put it back, and that will get us root 7. Don't forget you have root 7 outside. So you have 2 over root 7 cosine theta plus root 3 over root 7 cosine theta. So let's simplify it. Okay, let's simplify. So we will get to 2 sine theta plus root 3 cosine theta. So finally, the angle is small, and we are told that theta is small, so we can apply the small angle approximation on sine theta and cosine theta. So I have to indicate approximate sign. So 2 theta plus root 3, 1 minus theta square over 2. So as I simplified, we will be getting, okay, we'll be getting negative square root 3 over 2 theta square plus 2 theta plus root 3. So who is your P? What is your value of P and Q? So that is the value of P. Your P will be negative square root 3 over 2. Your Q will be 2. Yep, that's about it.